Okay friends, listen here. Today we are going to discuss about starting. This is the general organic chemistry one. So actually we completed general organic chemistry one. Today we are discussing about general organic chemistry 2 part 2 it is. So it is about fundamental concept of reaction mechanism, how reaction will be takes place and how product will be formed, how reaction totally converted. So we know that in any reactants substance will be there, attacking reagent will be there. So in presence of any type of solvent at a particular temperature and pressure, pump to the intermediate, product will be formed and side product will be formed. So coming to the here, reaction mechanism means this is totally reaction mechanism, how reaction is occur. Total we will discuss now. So in reaction mechanism, two words will become. First one, bond fusion. Bond fusion means cleavage or breakage of covalent bond. If you want to write notes, okay, write down. Next one, bond fusion. Bond formation. New bond will be formed. Here, first one, bond fusion is okay. Homolytic fusion, two types: homolytic fusion, heterolytic fusion. You have to remember homolytic fusion, heterolytic fusion, heterolytic fusion. Okay, homolytic fusion and heterolytic fusion. We will go through discussing about homolytic fusion and heterolytic fusion. Okay friends, here fusion are two types. Fusions are two types. Number one is homolytic fusion. Second one is heterolytic fusion. So what is the difference between homolytic fusion and heterolytic fusion? Here what is mean there? Homolytic means this bond will be cleavage takes place, breaking takes place in equal way, in equal halves. So this bond, actually one bond equal to two electrons. That's why this bond will be broken in equal manner. So this will get one electron, this one also get one electron. Here AB is there. Suppose AB, this also gets same when they are equal electronegative. Here means what? Here A and B are equal electronegative in nature. That's why this bond will be broken down into two particles, A free radical and B free radical. These are called free radical. So this is delta H nu. This is in presence of heat or sunlight. So I think it is a symmetrical cleavage of bond. So it is also form equal. It is also form, both are equal in forms. So symmetrical cleavage takes place. So here free radicals are formed. So this compound with one electron is called free radicals form. Here non-polar solvents are favorable. Non-polar means polar. Polar means what? Polar. Non-polar. Dipole moment is equal to 0 is non-polar. Dipole moment is there. It means polar. Okay. Free non-polar solvents mean example benzene. Total organic compounds are there, aromatic compounds. Those are called non-polar solvents. So peroxides, O2, etc. used as a catalyst. In this state, instead of heating or HNO, we can keep peroxides as a catalyst. Coming to this point here, this is homolytic fusion. So homo means same type of cleavage takes place. Heterolytic means hetero means different types. So it means, so bond if shifted to here, if among this A and B, if B has a more electronegative, so that bond will accepted by the B. It means B that is called attract electron from A. So that's why negative charge is there. Negative charge means what? Two electrons are there. So that's why the electrons from A is also accepted by B. That's why it will get B negative. That's why it means B has a more electronegative than A. So that's it. So this will get positive, this will get minus. That is not equal cleavage. So unsymmetrical cleavage of carbon bond is there. So carbocation maximum, this is called carbo. If carbon is there, this is carbocation. If carbon is there, carbanion. Positive charge is called carbocation, carbanion form. So electrophile, electrophile means what? Positive charge. Nucleophile means negative charge. Those are all are form of heterolytic cleavage. So it will occur at low temperature. Here polar solvents we have to use. Polar solvents is favorable. It means water, polar solvents, whatever may be. favorable. Acid base as a catalyst. Here peroxides as a catalyst. Here acid, whatever it may be, HCl, whatever, NOH, CH3COH, weak acid, we have to use as a catalyst for heterolytic fusion. Heterolytic fusion. So next we have to go for fission. Next see example for homolytic and heterolytic. So we didn't tell any example. So now you have to see. So this is homolytic. Homolytic means this bond will be breaks equally. This bond will be breaks equally here. Homolytic cleavage means in presence of sunlight or whatever it may be, heat or peroxide, what is there means. So CH3 radical will form, chlorine will be radical, free radical those are. So from each compound, Cl2 is also divided into here like this. It means same electronegative atoms are there. Chlorine radical, chlorine radical. Here coming to the heterolytic, not free radical. We form, this will be more electronegative, a bond will be shifted to on chlorine atom. That's why it will get negative charge. Hydrogen will get positive charge. Why? Because electron is loose. So from this here, chlorine has more electronegativity. That's why this bond will be shifted to here. One minus charge means how many electrons? 2 electrons. So the electron, one of the electron from this bond is takes out. That's why CH3 get positive charge. These are the example you have to remember. So we go for another topic. Next one here, types of intermediates are there. Types of intermediates are there. Types of intermediates. So here we go for multiplicity. Multiplicity means what? 2s plus 1. 2s plus 1. S is total spin. So spin, how can you find out? Suppose in P block actually 3 electrons are accumulated. 1, 2, 3. What is the spin value? This is 0. Spin value means this is 0. This is plus half. This is minus half. Okay. Yeah. How can you find out spin value? Total how many electrons are there? 3. 3 into 1. 3 half. 3 by 2. This is the spin value. So total how many electrons are there? You have to give for this one. Okay. Spin value it will be present after class. So here total spin it is. If S is equal to 0, what happens? Submit S value in 2S. What happens? Singlet will be there. Suppose 1, multiplicity is 1. So that is called singlet. If multiplicity 3 is there, that is called triplet. Okay. If more than 3, it is multiplicity. Okay. Multiplet. Okay. So among these, first of all, we go for study of carbocation. Cation means you know that positive charge species are called carbocation, and negative charge means you know that negative charge species are called carbenes. So here how many electrons are there? So actually carbon valence is 4. Carbon valence is 4. It means it has the capacity to bond with. It has the capacity to bond with 4 hydrogen, four other atoms, and it means 4 is capacity of 4 bonds. Capacity is 4 bonds. Here one bond is lost. Here totally 6 electrons are there. So 6 electrons are there. One bond contains how many electrons? 2 electrons. That's why 3 bonds are there. 6 electrons are there. Negative charge, positive charge means what? Nothing but electrons are lost. So 6 electrons. You know 1s2, 2s2, 2p6, whatever it may be. 6 is there. sp2 carbon. 3 bonds are there. sp2 carbon. If 4 bonds are there, sp3 I told you. So coming to this point, diamagnetic structure, diamagnetic in nature. If you find out this value, diamagnetic in nature. Diamagnetic means what? There is no unpaired electrons are there. Why? Because 6 electrons, so unpaired electrons will be there. Coming to this point, what happens? Positive charge, you know that electron deficient. If 8 electrons are there, it is called electron rich. If less than 8 electrons are there, it is electron deficient. Coming to this part, carbanion. Carbene is negative charge species. How many bonds are there? 3 bonds along with negative charge is there. Negative charge means how many electrons? I told you already. So one negative charge is equal to 2 electrons. So total how many electrons are there? 8 electrons are there. 8 means how it is undergoes 4 bonds is there. 4 bonds means I told you that sp3 hybridization done. So is it diamagnetic? Yeah. Why? Because 6 electrons are there. 6 electrons are there. Actually, it has to be get to 8 electrons. 8 electrons means 8 electrons it has to be get. 8 electrons means diamagnetic. 6 electrons means 2 electrons are gone. 2 electrons are gone means already unpaired, no unpaired electrons. If one electron gone, then only it will get unpaired electrons. So 2 electrons lost or 2 electrons gain. It means no unpaired electrons takes place. That's why both are diamagnetic. It is electron rich and negative charge. You are getting my point. Please write down in your notebook or copy to your notebook. Next third one is free radical is there, carbenes are there. Intermediate, first one is intermediates completed with that. First one is carbocation, then carbanion. Third one is free radical, fourth one is carbanion, fifth one is nitrens. We have to remember each and every concept. Why? Because they will ask NEET JEE mains advanced level. Free radical is there. Carefully listen. This is 3 bonds are there. 1 neutron is there. 1 neutral means how many electrons? Free radical it is. It means 1 electron is there. These are 3 bonds. 3 bonds means how many electrons there? 6 electrons plus 1. 7 electrons are there. Is it electron rich? No, electron deficient. Less than 8 electrons. So 3 bonds are this. I already told you. It is not completely minus. It means not exactly 8 electrons. That's why it is undergoes sp2 hybridization. 1 electron is there, unpaired electron is there. It means paramagnetic. Okay, neutral is this, not negative, not positive. So it is called neutral. Coming to this point here, carbenes. It carbenes and nitrogen. Listen, friends. It carbenes and nitrens. We have 2 types are there. Carbenes and nitrens. We have 2 types. First one is singlet, and the next one is triplet. So singlet means singlet. It is singlet and a triplet. Singlet carbon, only 1 lone pair of electrons is present in singlet. That means called single lone pair of electrons. That is called singlet. Here 2 pairs of lone pairs are called. So don't forget. Here single lone pair are there. Single lone pair of electrons is there. That's why singlet. Not it means 3 lone pairs are there, triplet. No, only 2 lone pairs are present. That's why triplet. Here 6 electrons are there. A triplet. This is also 6 electrons. But observe the structure. This is in bent form. So this is in bent form over. This is in straight chain is there. Straight line. Straight. So straight means what? Linear structure. Linear structure. At a linear spaces, linear structure. What is the hybridization? Linear structures. sp hybridization. You know that sp hybridization. You are getting my point. Here 1 lone pair is there, nothing but lone pair. 1 lone pair is there, nothing but sp2 hybridization done. Okay, sp2 hybridization. It is a diamagnetic. It has to be paramagnetic. Okay, lone pair of more number of lone pairs of electrons are there. Here paramagnetic is. Just listen. Singlets are diamagnetic. Triplet, only this one carbon triplet is paramagnetic. Coming to this point, nitrens. Already here nitrogen has lone pair, you know that. That's why leave it. It means extra how many lone pairs are there? 1 lone pair are there. So this is called singlet. This is called singlet. Coming to this point, what happened? This is called triplet. This is called triplet. Why? Because 2 lone pairs are there. Don't consider it is. Okay. Here same as it is, we have to consider. Already lone pair is there for nitrogen. Just remove it. Here listen, singlet. For singlet sp2. For singlet sp2. For singlet dia. But these are less stable. Coming to this point, triplet sp2. But here sp hybridization. Is this structure in linear form? No. So sp2 hybridization. It is also same as this paramagnetic, more stable. Okay. You have to remember this much of is there. First one is carbocation, carbanion. Third one is free radical. Fourth one is carbenes. Fifth one is nitrens. These are the intermediate, more important. We have to remember. You are getting my point. Okay. This is the main reason. Coming to the next point. Okay, guys. Up to here we completing the video. So next video we will discuss about stability of carbocation, stability of carbanion, stability of free radicals, how they will be vary. You have to the series will be there, order will be there. So we will discuss this concept in next video. Okay, so before this, please subscribe my channel, friends. Please accept this one. Why? Because I will upload videos daily, so tell your friends to subscribe and share to your friends. Okay, thank you. Bye friends.